We're going to talk about ratios, proportions, and triangle theorems. So on our warm-ups, we had our proportions. We know we just cross multiply. 12 times 2 is 24. X times 3 is 3x. Divide by 3, x equals 8. Same thing, letter B, we get a fraction, 20 over 3, or 6 2/3. Make sure it's simplified. Letter C, the only difference is you have to make sure that you distribute the 6 to both of those numbers. So 6 times 2 is 12, and 6 times x is 6x. Then subtract 12, divide by 6, and we get 4 over 3, or 1 1/3. Remember that a ratio is a fraction. It's a comparison of two numbers by division. It could be 1 over 2, 1 to 2, or 1 to 2, however you want to say it. Proportion is two or more ratios that are equal, so fractions that are equal. Cross product property means that we cross multiply and we just care what's diagonal from each other. It's A times D, well, they're across from each other here and here. B and C are across from each other no matter what. So if we're looking at some word problems, 8 math problems goes with 10 minutes, so they go together. How many can do in 45 minutes? Well, everything that has to do with the number of problems is in the numerator, so 8 and x, because that's what we're trying to figure out. And the minutes goes in the denominator, 10 and 45. Cross multiply, solve for x, we got 36 problems. Same thing here with my fantastic recipe of Sour Patch Kids and Skittles. 3 to 5 ratio. 3 is a Sour Patch, so if I want 86 Sour Patch Kids, I don't know the number of Skittles, so that's in my denominator. Everything goes across, and it goes down. So everything matches up. Model, same thing. Model is the smaller one, so 1, and the mansion is 35. So in the scale model, the movie screen is 3 inches by 5 inches. So we have two proportions. First we have 3, and we need to figure out what number in the real mansion goes with that, x, and we have another one, 5 over y. So we take it separately. First we look at 1 over 35 equals 3 over x, cross multiply, x equals 105. Then we do the same thing with the first and third. 1 over 35 equals 5 over y, cross multiply, we get 175 inches. But we wanted it in feet, so we divide by 12, which is what we did here. We get 8.75 feet, and 14.58 feet approximately, we rounded. Moving on to our triangle theorems, our mid-segment theorem tells us that if we connect two midpoints of a triangle, so this and this are in the middle, and we connect them, then these two lines are parallel, which isn't as important for what we're doing, but we also have that DE is half of AB. This segment is half of all of this. Side splitter theorem, very similar, except we have parallel lines. We don't know that they're the midpoint. I don't know that D is in the middle of A and B, or E is in the middle of B and C. What I do know is that they're parallel, so this segment over this segment is going to equal this over this. Just set up the fraction like it is. BD over DA equals BE over EC. And the parallel line theorem is the same thing, but now we're dealing with 3 parallel lines. But again, it's still this over this equals this over this. So again, it's just setting up proportions with segment lengths. So number 8, if you turn yourself, you can see that the pair lines are here, so it's x over 12 equals 15 over 9. That's all we did, cross multiply. Number 9 is a better example where it's the right orientation. 12 over 5x equals 8 over 10. Just all you do is add in the fraction bars and the equal sign there. Same thing with 10, but again, you kind of have to turn it. That's the equal sign, that's the fraction bars. So we have a whole bunch of that. Very similar, you can run through the examples yourself, it's not that difficult.